In this segment of the lesson, we will examine how to test economic models. We've spent a considerable amount of time explaining the nature of an economic model, and in this lesson we have also explored different forms that data come in. It's now time to see if we can confront our economic models with some data and see what conclusions we can draw from having done that, and see what inferences we can make about the behavior of economic agents in the economy at large. So we're going to start with a statement of a very simple economic model that we have up here. We're going to have a simple version of the model, and this will be part of a broader economic model. So the simple statement of the model is that we have a relationship between mortgage rates on the one hand and the behavior of house prices on the other. When we investigate this relationship, we're not saying that mortgage rates are the only things that influence house prices. In a broader perspective, we would recognize that house prices are a function not only of mortgage rates, but also the incomes that people have who are buying those houses. The price of houses would also depend upon supply conditions in the economy. They would also depend upon what the growth in the population is, whether rents are high or low, and perhaps several other factors as well. So here we have a very general statement of a broader model stating that there is a relationship between house prices on the one hand and a whole variety of other influences on the other. When we write the model in this general form, you'll notice that we have used the letter F here. And F is just a shorthand to denote the fact that we are imagining house prices to be a function of all of the things that we write in parentheses that follow the letter F. So it's just a shorthand to denote the fact that there is a functional relationship envisaged between the variables inside the parentheses on the right-hand side and the variable on the left-hand side. But if we're going to look at economic relationships in two dimensions, then we're restricted just to look at one of these influencing or determining variables on the right-hand side, given that we have the left-hand side variable on the other axis. So how do we go about testing or specifying a relationship between mortgage rates on the one hand and house prices on the other? Obviously, we have to get some data, and we have to use the data in a way that enables us to draw some conclusions from it. Here are some real data for the years 2007 through to 2010. They are in quarterly form, and the first column of the table denotes the time period in which the values occur. The second column of the table gives us the conventional mortgage rate, and we can see that that moves around over the period. And in the third column, we have constructed a price index for housing, and those values are given in the final column. We know at this point that we could construct a scatter diagram, or we could plot the data in the second and third columns here. And if we were to do that, we would get a whole series of points in two-dimensional space. So we will put the mortgage rate variable on the vertical axis, and we will put the house price variable on the horizontal axis, and we will take all these pairs of data and plot them as points in that kind of a diagram, and then we'll see what we can do with the data patterns that emerge from that. So the first data combination is a mortgage rate of 6.5% and a house price index value of 108.4. So since this is a combination of two values, we can plot it as a point in a two-dimensional diagram. If we were to take all of the combinations in the table, we would get a point representing each combination of mortgage rate and house price. What would that look like? So, the name we give to the resulting diagram is called a scatter plot. It's a scatter plot because it's a scatter of points that we plot in two-dimensional space. And then what we'll do is we will draw or fit a regression line to these data points, and this regression line will summarize the relationship between the two variables when we think of the variables in average form. Here then is a plot of the data from the preceding table. Each value here represents one time period. So the value of 6.5 and 106 on the house price index is the first value in the table, and each one of the other points likewise represents a similar combination. So, for example, in 2008, we had in one of the quarters a combination of a mortgage rate of 6.75% and a house price index of 157.2. We see in these points in this scatter plot that there is, broadly speaking, a negative relationship in the data. That is to say, the points form a downward sloping pattern. And we could represent that downward sloping pattern by a line that goes through the points and represents these points in a reasonably accurate fashion. If we were to draw such a line, and there are techniques and criteria for drawing such a line, then we call that a regression line. A regression line is a line that describes and fits the data as well as possible. Evidently, if the points or the dots are closer to the regression line, then the regression line is a better description of the relationship between the two data series. We say that the fit is better, and therefore there is stronger support for the model. In this particular example, the data do support the theory that is expressed in the model. The theory that we developed earlier in the chapter is that at lower mortgage rates, people can afford higher monthly payments, therefore they are willing to pay more for their house, and consequently that may put upward pressure on the price of housing. And so when we draw this scatter plot, we see that there is indeed a negative relationship between mortgage rates and prices. You'll note that in the context of the broader model that we described a few moments ago, there are other influences on the price of housing quite apart from the mortgage rate. If incomes were higher, people might be willing to spend more on housing, and that might put higher pressure on house prices at any given mortgage rate. But we will examine how these other influences, which are not mapped in our two-dimensional diagram, enter into the determination of the variables in the next lesson. Now, how do we go about drawing a line or fitting a regression line through the data that represents the scatter plot in an accurate way? Econometrics is the science of quantifying relationships, and econometrics is made up of two words. The first part of it is from economics, obviously, and metrics is the science of measurement. So econometrics is the science of quantifying relationships between economic variables. The regression line, as we said already, shows the average relationship between the variables. Can we now progress to write down a simple algebraic form for the regression line that we have drawn through these points? Let's imagine that we took the regression line that we specified a few moments ago, and we projected that regression line so that it met both the vertical axis and the horizontal axis. If you go back to our earlier diagram, you will notice that at the lower part of the vertical axis and at the lower values of the horizontal axis, we are not at zero. So we're going to imagine, in order to keep things simple, that the regression line we specified in that slide meets the mortgage rate axis at a value of 9, and that it meets the house price index at a value of 540. What do the intercepts tell us? This value of 9 up here, as we saw in Chapter 1, represents the value that the variable on the vertical axis takes on when the value of the variable on the horizontal axis is 0. Likewise, the value of 540 assumes that the value of the variable on the vertical axis takes on a value of 0. Now, of course, we never actually observe 0 values for a house price index or 0 values for a mortgage rate, and that's why we usually deal with a segment of this regression line to represent reality rather than the whole line where it is specified to meet the axes. But it's convenient for us to take the working part of the regression line and project it to the axes, because that helps us to write down a simple linear equation that describes the regression line or the part of the regression line that we're interested in. Now that we have defined the intercepts, the values of the variables where the line meets the axes, we're also in a position to define what the slope of the line is. The slope of the line, as we know, is the vertical distance divided by the horizontal distance, also known as the rise over the run. In this example, the slope of the regression line is 1 over 60. It is the vertical distance of 9 divided by the horizontal distance 540, and that is 1 over 60, and we have a negative sign in here as well. This is negative because the relationship is downward sloping. So that slope, if we divide 60 into 1, we get minus 0.0167, and that is going to be the slope of the line that defines the relationship between the mortgage rate and the house price index. So we now have a pair of intercept values and we have a slope for the line. So can we write down an equation for the line? We can. Before doing that, notice that we can take any pair of points on this regression line, and if we read off the corresponding values on the horizontal and vertical axis, it should be the case that they bear the same relationship to each other as the intercepts do. So if we were to go from a value of the mortgage rate of 4% to a value of 5%, the value of the house price index must decline by 60 units because the slope is 1 over 60. So a unit rise in the value of the variable on the vertical axis brings about a 60 unit reduction in the value of the variable on the horizontal axis. So how do we write down the equation for the regression line? Well, we've already said that we assume the regression line intersects the axes at these two values. We know what the slope is, and hence the regression line can be written in this way. Let's look at the first part of, or the first specification of the regression line. We know that at the vertical intercept, the value of the line is 9. At the vertical intercept, we know that the value of the variable on the horizontal axis, the price of housing, must take on a 0 value. So at the vertical intercept, the mortgage rate is 9, and that happens when pH is equal to 0, so the second term drops out of the equation. We know that the slope takes on a value of 1 over 60, and so for every 1 unit change in the value of the mortgage rate, we get a 60-unit change in the price of housing. Now, anytime we have a linear equation like this, we can always take the variable on the right-hand side, in this case pH, and rewrite the equation by bringing it over on to the left-hand side and isolate pH, and we can get another form of the same equation. If we start off by multiplying across this left-hand side by 60, we would get 60 times the mortgage rate is equal to 9 times 60 minus 1 over 60 times 60, which is 1. We now have a 1 in front of the price of housing, which is what we have in the second specification. And if we bring that over to the other side of the equation and rearrange things, we get the specification that's on the right-hand side. This is just another way of writing the equation. To check that it is correct, we could say, what is the value of the mortgage rate, which will yield a price of housing of 540 units on the index scale? To obtain a price of housing of 540, this last term here would have to be 0, so the mortgage rate would have to take on a 0 value in this imaginary extreme case. So what we have done here is we have managed to take some data from a table. We have drawn a scatter plot in a diagram. We have drawn a regression line through the data that we think accurately represents the relationship between the two variables. We have projected that regression line to the two axes, and once we do that, we know what the intercepts are, we know what the slope is, and so we can write down a simple equation for the linear model relating the mortgage rate to the price of housing. This simple model that we have drawn, or that we have developed on the basis of observed data, tells us the following. If we take this final version of the model here, this final statement of the model, it tells us that every time we change the mortgage rate by 1 point, the price index of housing will change by 60 times that mortgage rate. So we have an economic model here that has empirical content and that is based upon actual observation of the data. We have been able to scientifically develop a model which specifies a precise empirical relationship between two economic variables.